Hello, today we're going to go over the last exam 4. So it shouldn't take too long since most of you know the answers. So problem 1, I do believe problem numbers are correct, or question 1. A gas occupies 6.25 liters at 1.02 atmospheres. What will be the new pressure if the volume was decreased to 1.25 liters? Assume temperature N is constant. So we have Boyle's law here. And since the volume decreases, you would expect the pressure to increase. So pressure should increase here. So if you plug in it correctly, so P2 is equal to P1 V1 over V2. Okay. And you should get 5.10 atmospheres. Now, some of you got it wrong because you picked the one with the incorrect number of sig figs. So it should be 5.103 sig figs. Right. Any questions? Okay, for problem 2, a gas occupies 255 milliliters at 12 degrees C. The volume changes to 805 milliliters. What is the new temperature in degrees C of the gas? Assume pressure N is constant. So now we have Charles's law. Since the volume is increasing, the temperature should increase. But remember, the temperature needs to be converted to Kelvin. So we would have, 12 degrees Celsius is 285 Kelvin. Then you multiply that by 805 milliliters over 255 milliliters. And that would give you 900 Kelvin, which is 627 degrees Celsius. And again, the 900 Kelvin has 3 sig figs and no decimal place. So your degree Celsius should have no decimal place. So you have to round it so it has no decimal place. So it would be 627 degrees Celsius. All right. And in problem 3, what volume in milliliters was 705 milliliters of a gas at 22 degrees Celsius and pressure is 1.42 atmospheres occupied when the conditions changes to minus 16 degrees Celsius and 0.985 atmospheres. So they want V2 here, if we do this correctly. So V2 is equal to P1 V1 over times T2 over P2 times T1. So again, temperature has to be in Kelvin. So we have P1 is 1.42 atmospheres times V1, which is 705 milliliters, times T2, which is 257 Kelvin, over P2, which is 0.985 atmospheres, and over T1, which is 295 Kelvin. Okay. So the temperature is, okay, the temperature is decreasing, so that should decrease the volume. But the pressure is decreasing, that should increase the volume. So actually we get an overall increase. It should be 885 milliliters. Okay. Any questions? Okay. Now, question, I think 4. As the pressure of a gas increases at constant temperature, its volume will increase or decrease, assuming the amount of gas is constant. Now, some of you got this wrong, but I corrected it on most of them. You need to spell it exactly like they have as a possibility in this type of filling. So you need to put decrease, not decreases. Okay, remember, pressure and volume are inversely related. Okay. Number 5, I do believe. 2 hot gas helium balloons, X and Z, have the same volume and gas pressure, but the gas temperature in balloon X is lower than in balloon Z. Which balloon contains the gas with the lower density? Okay. Now, density is inversely proportional to temperature. So, if we want the one with the lower density, we want the one with the higher temperature. So that would be balloon Z. Okay. So again, you need to pick the correct choice. Okay. So problem 6, I do believe. How many grams of nitrogen gas can be in a balloon with a volume of 12.3 liters at STP? Now, this is shouldn't be that hard because it's at STP. So we can take the liters of nitrogen gas, times that by 1 mole over 22.4 liters, and times that by the molar mass of nitrogen, which is 28.02 grams over 1 mole. And that will give you 15.4 grams of nitrogen. Now there's other ways to do it. You can also plug in to using the version of the ideal gas law. The mass is equal to pressure times volume times the molar mass over RT. Again, the pressure has to be in atmospheres, the volume in liters, and temperature in Kelvin. And that should give you the same answer. Okay. In problem 7, how many moles of a gas will be in a 7.25 liter container at 747 torr and 295 Kelvin? Show work. So you can just plug this in since they want to find how many moles. Plug into the ideal gas law, N is equal to PV over RT. But again, pressure needs to be in atmospheres. So you can just take 747 divided by 760, and that will give you the pressure in atmospheres. Times that by 7.25 liters. This will be over R times T, and T is 295 Kelvin. That was given. And you should get 0.294 moles. Any questions? You can also use the molar volume, take the 7.25 liters, times that by 1 mole over 22.4 liters, but you're not at STP, so you have to make a correction. You have to put the real pressure on top, the standard pressure on bottom, times that by the standard temperature on top over the real temperature on the bottom. And that should give you the same answer. Any questions? Now, I do believe this is problem 8. Okay. This is the molar mass problem. If 2.401 grams of unknown sample gas, pure, occupies 0.720 liters at temperature 298 Kelvin and a pressure of 0.995 atmospheres, calculate its molar mass in grams per mole. Now, the easiest way to do this is to use the version of the ideal gas law. the molar mass is equal to mRT over PV. And this, you're given the mass, you know what R is, T is given, pressure is given, and the volume is given. So you just plug in. Now, none of the choices were correct. The correct choice was 82.0 grams per mole. That's what you should have calculated. But none of the choices are there. There's 820, there's 819, but that's 10 times greater than the result. Okay. The other way you could have done that is find the number of moles by using N is equal to PV over RT, and then that will give you the number of moles. Or you can use the molar volume. Take the liters times it by 1 mole over 22.4 liters, times it by P real over P standard, times it by T standard over T real. They will both give you about 0.0293 moles. And therefore the molar mass would be, take the grams over the number of moles, and that would give you approximately 82.0 grams per mole. All right, any questions? Problem number 9. Okay. Now, this is Dalton's law. So you have to apply Dalton's law. So here I gave you 4 gases. I gave you the number of moles of all 4 gases. So what you need to do is find N total. N total is 3.0000 moles, has 4 decimal places. Since all the moles had 4 decimal places, so your answer should have 4 decimal places. Okay. So I asked you for the partial pressure of helium. So the pressure of helium is equal to the number of moles of helium times PT over NT. And since the number of moles of helium and the pressure total have both 4 sig figs, your answer should have 4 sig figs. So if you plugged it in correctly, you should have got 178.9 millimeters of mercury. So that would give you, and again, that's 4 sig figs. Okay, problem 10. Hydrogen gas was collected over water if 1.120 liters sample of hydrogen gas is collected as a temperature of 25 degrees Celsius and a total pressure of 762.8 millimeters of mercury. How many moles of hydrogen gas were collected? Show work. Well, you don't have to show work. But, and it's given the vapor pressure of water at 25 degrees Celsius is 23.8 millimeters of mercury. So what you need to do here is find the pressure of hydrogen gas. So the pressure of hydrogen gas is equal to the total pressure minus the vapor pressure of water, and that will give you 739.0 millimeters of mercury. So you can just plug, so using that pressure, you can find the number of moles of hydrogen gas by using the ideal gas law. N is equal to PV over RT. The pressure will be 739 over 760. That will give you the value in atmospheres. Times that by the volume over R over the temperature in Kelvin, which is 298 Kelvin. And that should give you approximately 0.0445 moles of hydrogen gas. Okay. So that would give you 3 sig figs. Since the R value only has 3 sig figs and Kelvin only has 3 sig figs, you should have 3 sig figs. So even, because if you use 0.0821, that only has 3 sig figs. So this should be rounded to 3 sig figs. And remember, the zeros in front do not count. The other way you could have done this is take the volume of hydrogen gas, times this by 1 mole over 22.4 liters, and then times this by P real over P standard times T standard over T real, and that will give you the same answer. Any questions? Okay. So I think this is problem 11. Calculate the molarity of a solution made by dissolving 68.50 grams of succinic acid in ethanol with the final volume of the solution equal to 375 milliliters. Show work. Given the molar mass of succinic acid is 118.09 grams per mole. So you just put the grams of succinic acid over 375 milliliters of solution, times this by 1 mole over 118.09 grams, that would give you the moles. And then times this by 10 to the third milliliters over 1 liter, that would change the volume of solution to liters. So you have moles per liter. But this should have 5 sig figs because your mass has 5 sig figs, your volume has 5 sig figs. So the answer should be 1.5468 molar SA solution. Any questions? Okay. Now the next problem. How many grams of sucrose are needed to make 1.750 liters of a 0.1270 molar aqueous sucrose solution? So again, the molar mass of sucrose was given as 320.30 grams per mole. So you can take the liters of the sucrose solution, times this by the molarity, and that would give you the number of moles. Then times this by 300, times this by the molar mass, and that will give you grams of sucrose. You should get 4 sig figs and 76.08 grams of sucrose. You should have 4 sig figs. Okay. Some of you got it wrong because you picked the wrong one or didn't have the correct number of sig figs. Okay. Number 13, I believe. Okay. How many milliliters of 0.1270 molar aqueous glucose solutions needed to provide 0.00520 moles of glucose? So you can start with the moles of glucose and then times this by 10 to the third milliliters of glucose solution over 0.1270 moles of glucose. Okay, and that should give you, everything has 4 sig figs, so that should give you 40.94 milliliters of glucose aqueous solution. Any questions? Okay. So I think problem 14, if 50 milliliters of 7.50 molar aqueous nitric acid solution would dilute it with water to a total volume of 750 milliliters, what is the molarity of this new solution? So again, here V1 is 50 milliliters, M1 is 7.50 milliliters, and V2 is 750, not 800, because that's the total volume was given as 750. So you would take 7, so M2 would equal M1 times V1 over V2. And this should have 4 sig figs, 0.5000 molar nitric acid solution. Any questions? Okay. So the only essay question on the first part, this is question 15. Provide a balanced chemical equation when aqueous lead-2 nitrate solution reacts with aqueous sodium bromide solution. Indicate the expected physical state of each compound at room temperature. Okay. So this was, okay, so lead-2 nitrate is Pb, NO3 in parentheses, subscript 2, aqueous, plus 2 NaBr, aqueous. This will give you PBr2, PbBr2, solid, plus 2 NaNO3, aqueous. And that would be the balanced chemical equation. Okay. Now for problem 16, what volume in milliliters of a 0.360 molar aqueous lead-2 nitrate solution is needed to precipitate all the lead as lead-2 bromide from 42.0 milliliters of a 0.310 molar aqueous sodium bromide solution. Now, this sort of gave you a hint in 16 that I told you that the lead-2 bromide, the lead is precipitated as lead-2 bromide. So I gave you a hint in problem 15 that the PbBr2 should be a solid. So you're given the volume of sodium bromide, you're given the molarity of the sodium bromide, you're given the molarity of the lead-2 nitrate. They want the volume of lead-2 nitrate. So you can find that, you can take the volume of, in milliliters, of the sodium bromide aqueous solution, times this by 0.310 moles of sodium bromide over 10 to the third milliliter of sodium bromide aqueous solution. Then times that by 1 mole of lead-2 nitrate over 2 moles of sodium bromide, because that's the mole ratio, times this by 10 to the third milliliters of lead-2 nitrate aqueous solution over 0.360 moles of lead-2 nitrate, and this should give you 18.1 milliliters of lead-2 nitrate aqueous solution. And again, everything, you should have 3 sig figs here. All right. Okay, so that was the first 100. Does not include any bonus. Okay, so problem 17. Hello. So I think it was question 17. Consider the following balanced equation. You have 2 propene gas plus 9 O2 gas will give you 6 CO2 gas plus 6 H2O gas. That's a combustion reaction. If 39.0 liters of CO2 gas is produced at constant pressure and temperature, how many liters of propene gas at the same temperature and pressure must have reacted? So you can take the 39.0 liters of CO2 gas. And the mole ratio here is 2 to 6. So you times this by 2 liters of propene gas. over 6 liters of CO2 gas. This should give you 13.0 liters of propane gas. Again, that should have 3 sig figs. Okay. Because remember, the mole ratio has infinite number of sig figs. In this case, the volume ratio. Now, problem 18 is to figure out how many grams of lead-2 bromide was produced in question 16. Okay. So, if you take the volume of sodium bromide solution used in milliliters times this by 0.310 moles of sodium bromide over 10 to the third milliliters of sodium bromide aqueous solution, this will give you the moles of sodium bromide, which would be 0.0130 moles of sodium bromide. If you multiply that by 1 mole of lead-2 bromide over 2 moles of sodium bromide, times that by the molar mass of lead-2 bromide, which was given as 367.0 grams per mole, that would give you 2.39 grams of lead-2 bromide. Okay. And that would have 3 sig figs. It should have 3 sig figs. Okay. Any questions? Okay. So problem 19, I do believe. Provide a balanced chemical equation when calcium oxide reacts with nitric acid and indicate the expected physical state of each compound at room temperature. Some of you did not do that. So calcium oxide is CaO, and that was given as a solid, plus 2 nitric acid, and again, that would be 2 HNO3 aqueous, will give you calcium nitrate aqueous, which would be CaNO3 in parentheses, subscript 2 aqueous, plus H2O liquid. You're not heating it, so it's water is a liquid here. Okay. So problem 20, determine how many grams of calcium oxide will react with 395 grams of 11.5% by mass aqueous solution of nitric acid. Show work. So what you need to do here is take the grams of solution of nitric acid, use the mass percent to give you grams of nitric acid, and use the molar mass to give you moles of nitric acid. Use the mole ratio to give you moles of calcium oxide, and then use the molar mass of calcium oxide to give you the grams of calcium oxide. So you take 395 grams of nitric acid solution, times this by 11.5 grams of nitric acid over 100 grams of nitric acid aqueous solution, times this by 1 mole of nitric acid over 63.2 grams of nitric acid, times this by 1 mole of calcium oxide over 2 moles of nitric acid, times this by 56.08 grams of calcium oxide over 1 mole of calcium oxide. And that should give you 20.2 grams of calcium oxide, 3 sig figs. Okay. So that would be your best answer. Okay, problem 21. Provide a balanced chemical equation where magnesium metal reacts with hydrochloric acid and indicate the expected physical state of each compound at room temperature. So magnesium metal is a solid, so it's Mg solid plus 2 HCl aqueous will give you magnesium chloride, MgCl2 aqueous, because most chlorides are soluble, plus H2 gas. So problem 22, what will be the volume in liters of a hydrogen collected at 24 degrees Celsius and 749 millimeters of mercury if 1.050 grams of magnesium is completely reacted with excess hydrochloric acid. So you can take the grams of magnesium, change that to moles of magnesium by using the atomic mass, which was given, and then use the mole ratio to give you moles of hydrogen gas. And then you can find the volume of hydrogen gas by using the ideal gas law. V is equal to nRT over P. Or you can use the molar volume, okay, with correction. So you can take the 1.050 grams of magnesium times this by 1 mole over 24.31 grams, times this by 1 mole of hydrogen gas over 1 mole of magnesium, then times this by R times the temperature in Kelvin, 297 Kelvin, over the pressure in atmospheres, 749 divided by 760 atmospheres, and that would give you 1.07 liters of hydrogen gas. The other way you could have done that is after you use the mole ratio, times this by 22.4 liters per mole, then times this by P standard over P real, times this by T real over T standard. Make sure that anytime you do this, the temperature has to be in Kelvin. And that should give you the same answer. Okay. All right. So again, on tests, you need to, multiple choice tests, you need to make sure you pick the best choice, and your answer should have the correct number of sig figs. Some of you are getting things wrong because you're not reporting it to the correct number of sig figs. All right, any questions? All right, so if you have any questions, send me an email through Canvas. All right, so this is it for now, and I'll finish the review for your final later this week. All right, you guys take care. Bye.